Okay, we're now recording. This is for A period homework review on Thursday, October 22nd. Number 19 of the 3.3 homework. This is on page whatever. It's 3.3. So you could do this a few ways. You could do a product rule at the top if you so desire. It's because you do see two things being multiplied here, right? So that could be a product rule. Yikes. Let's take care of that. That could be a product rule if you so desire. And then whatever, but the problem is that you also have to combine with a quotient rule too. So it becomes very complex. And I guess the way you would do it is you start by the quotient rule actually. So let me backtrack a little bit. You actually start the quotient rule where you take the derivative of this times that kept intact minus this kept intact times the derivative of that. But then when you do the derivative of this, then you got to do the product rule within the quotient rule. It's really, really messy. I would strongly suggest that you expand this. So it's not quite FOIL because you don't have two terms here and two terms there, but it's kind of like FOIL, right? So I'm going to multiply x to each of the three terms in the second group. I'm going to multiply -1 by each of the three terms also in the second group. And if you do it, things will come out actually really, really nicely. I'm going to do it in this little space down here. So you should have x cubed plus x squared plus x minus x squared minus x minus 1 all over x cubed. So I'm just simplifying. I'm not doing any calculus whatsoever, just straight up algebra. Now, can things cancel? Absolutely. This is the fun part. X cubes cancel. Sorry, the x cubes don't cancel. Crazy. X squares cancel. X is cancel. What's left up top? Of course, x cubed minus 1 over x cubed. Now, you can just do the straight up quotient rule and you're good. And you just go through the motion, do quotient rule. I got something better. I'm going to break this down even more. See, whenever you have a monomial, right, this is getting a little creative. And we're going to do product rule, quotient rule. We're going to do all these rules like forever now, right? And I'm going to throw you guys different situations. Kind of like, I'm not sure you guys watch baseball. I know World Series has a low rating, but I love baseball. And so I love what Tampa's doing because Tampa, they have all these different like pitchers and you have all these different arm angles and there's all these different like scenarios that could happen. And this is what this is kind of like. It's kind of like, you don't know what you're going to get. Like maybe I'm throwing a curveball, maybe I'm throwing a fastball. Like you have change up, curve, or I already said curve, a slider. There's so many different things that can come your way. You have to react based upon that. So in this case, the way I'm reacting is that, oh, I see an opportunity to FOIL and then divide by x cubed. See, I can do x cubed over x cubed. When you have a monomial, you have that liberty of breaking up the fraction this way. We did this during limits, right? So what does y equal now? Y equals 1 minus x to the -3 power, right? Because x cubed is 1 over x cubed x to the -3. Again, I haven't done any calculus yet. All I've done is just simplifying. I FOILed up top, FOILed, clean it up, then divide each term by x cubed. When you have a monomial, you can do that. When you have one term at the bottom, you can do that. Now, just take my derivative. Easy peasy. Derivative 1 is 0. That's going to be negative of -3 times x to the -4. 3 over x4. Done. There we go. So that's how you do 19. Okay, 21. 21, you're going to have to use quotient rule. Now, there's another rule that we will learn down the road called the chain rule, which you would combine with the product rule. I'm not going to talk about that process because we're not there yet, but I will revisit that down the road. This kind of problem here, we'll use a different technique. But in this case, we just use quotient rules. So remember, y prime will equal low d high, which is 2x, minus high times d low, which is -3x squared, over low squared. And away we go. So that's going to be 2x minus 2x4. Then you have -x squared times -3x, so it's positive 3x4. All over 1 minus x cubed squared. Clean it up, -2x4, 3x4. You get that, plus 2x, and the bottom squared. Leave it as that. I would not bother foiling the bottom. It's a waste of time. So that's 21. And again, as I'm going through these, whoever did ask about, or if anyone else is curious, if you're still kind of confused, just let me know. Just put something in the chat. That's how that's done. Okay, someone asked about 23D. So this is straight up the derivative of each of these individually. So derivatives can be 7v prime. Yep, sorry about that. 7v prime minus 2u prime. Derivative of v prime is 2. Derivative of u prime is -3. Remember, we have two terms being added or subtracted. You do the derivative of each of those independently, right? That's part of our addition to one of the rules we had for 3.3. So 14 minus -6, you get 20. That's you get 20 for that one. Okay, let's keep moving. Let's take a look at 27 and 31 since someone asked about that. Okay. Okay, reposition. Okay. 27, you have to find the equation for a tangent line to the curve at the given point. So you're going to have to do a derivative, right? Remember, equation lines are this. The textbook, I don't know why, they like to put the answers in slope-intercept form. I think it's kind of lame that they just leave it in point slope form. I don't know why they do that. Love to talk to the editor and figure out what were they thinking. But anyway, y prime is going to be low, d high, minus high, d low, over low squared. So that's going to be 3x3, no, 6x3. And by the way, if I make any mistakes, please correct me. I'm human. I am going to make mistakes. Minus 2 over 4x squared. 4x cubed minus 2 over 4x squared. Now, if I plug 1 in, I should get 2 up top and 4 down below. So my slope is 1/2. So I'm feeling good about that because I see 1/2 here. And if I do my point slope form, I'll do it right below here. Y, if I plug in 1, I think you get 2 as your 2 over 2. So the y coordinate's 1 when x is 1. 1/2 x minus 1. If you distribute and work it out, you should get that. So that's 27. So again, you probably made some careless mistakes for missing these. 31. Oh boy. Okay. So quotient rule, right? Y prime is going to be low. D high, which is going to be 1/2 times x and -1/2 minus 0. Remember, that's x at 1/2 power, right? So you move the 1/2 to the front and then drop the exponent by 1. Or 1 over 2 root x, we've talked about that. Minus the high times d low, which is 1/2 x and -1/2 again, plus 0, all over the low squared. So yeah, then you have to, at this point, you're fine. Don't bother simplifying. You're gonna get what you get there. I mean, if you were to simplify it, I mean, I suppose I could do it really quickly because someone did ask about it. Remember, this right here is 1 over 2 root x. Likewise over here, 1 over 2 root x. So if you distribute, you get 1/2 plus 1 over 2 root x minus 1/2, and then minus a negative, so it becomes plus 1 over 2 root x. So there's a lot of like minus negatives, and of course root x plus 1 squared. Those cancel, you get 1/2, 1 over 2 root x plus 1 over 2 root x. That's going to be actually 2 over 2 root x. You get 1 root x over all that's junk. And that's how you get the answer 1 over root x on the bottom. So, yeah. But I'm not going to give you guys something like that on our test because I think it's just a little much. Notice I kind of just chuckled when I saw that because like I knew it was just a little crazy. Third one I like a lot. If you're parallel to the x-axis, what's your slope? It's going to be 0, right? So you're going to take the derivative of this, which is easy. 6x squared minus 6x minus 12. Set that bad boy equal to 0. So 0 equals 6x, and right factor, no, sorry, just 6. X squared minus x minus 2. X minus 2x plus 1. X is 2 or negative 1. There you go. And just plug in 2 or negative 1 to the original function to get the y value that goes with it. So that's there. I like 39 a lot. That's something we could have on our test. Probably multiple choice. Maybe I might do that. Who knows? 41. I've never heard of that before. Newton serpentine, whatever. Maybe the graph looks like a snake pattern serpentine. I have no idea. We have to find the tangents. Okay. Excuse me. Well, y prime. So x squared plus 1 times 4, doing quotient rule, right? 4x, x squared plus 1 over x squared plus 1 squared. So clean it up. You should get 4x squared plus 4 minus 4x cubed minus 4x, oh boy, over x squared plus 1 squared. I'm not going to bother doing any more factoring or anything like that. I'm just going to plug 1 in now because I need to see, and also x equals 0 because you have to do it at the origin. If I plug in 0, I get 4. My slope is 4. If I plug in x equals 1, 4 plus 4, all that just goes away. So you just get 0 as your slope. And then you do y minus y1 equals m times x minus x1. Work it all out. And you will get, you just work it out, yeah. I don't know. Plug in 0, 0. 4x minus 0. So you get y equals 4x. And then plug in 0 for m. And of course, 2 for y1, 1 for x1. You should get y equals 2. So. Worksheet 2, number 15. I have that open ready. So just, you know, worksheet 12 was just using a lot of the power rule stuff we talked about. But one thing that you might want to do for this stuff is like 3 over x cubed, make it 3x negative 3, then do the derivative. Or negative 2 fourth of x, make it negative 2 times x to the 1/4 power, then do the derivative. Just easy if you can convert any fractions with x in the bottom to negative exponent or any radicals into fractional or rational exponent. That'll make the power rule just more streamlined, just so you know. For 15, we do blue here for a bit of contrast. So f prime of x will be the 2/3. That's your constant. Move the exponent to the front. So 2/3 times 3/2 times x, and then drop this by 1. 3/2 minus 1 is 1/2. Those cancel very nicely. Minus 3/4. Move the 3/5 to the front. Times x, and subtract that by 1, negative 2/5. So you get 9/20. X at a half minus 9/20 times x to negative 2/5. And that's how you get that. 17 and 18 are a little funky. Remember, these are constants, so you don't take the derivative of a constant. I mean, we do, it's just gonna be 0, so 0. And in here, but the constant is like a coefficient, right? It just comes along for the ride, and you just focus on the x part. Obviously, I dropped exponents by 1 here, move 3 to the front, 3c to the front. There you go. Okay. Any questions?
I have a question.
Yeah, far away.
Would be easier to ask here than the chat.
Yeah.
For something like number 15, do you really care how we like write the answer? Because I wrote it as like root x minus 9/20 times like 5th root of x squared.
I don't care. Actually, I'm going to prefer you guys keep it. So what I'll probably do, just so you know, actually, I'm glad you brought this up because you're probably going to save me a major headache for myself when I'm grading. Something like number 15, I'll probably put as multiple choice. And I'll probably just leave the choices like negative exponents like you see here. If I do something like 15 as a free response, then I could see a variety of responses and people making potential mistakes. Or people ask me questions like, oh, do I have to do this or that way? And I didn't think of those questions, and all of a sudden I'm answering, and that's slowing things down. So, so no, I don't care. Actually, in fact, I prefer you leave as a negative exponent, and I'll probably do this multiple choice because you're going to see that anyway when you're doing your work, and then you just know to stop, right? But yes, I mean, you could, if you so desire, do that, the 5th root of x squared, and then you can rationalize it if you want to do that too. The 5th root of x cubed times the 5th root of x cubed, or what if it was like x and negative 7ths, sorry, x and negative 7/5, that's 1 over the 5th root of x to the 7, then you have to pull out an x to the 5, and then it just gets really messy. So I'll in all likelihood, I'll probably put this as multiple choice. That I think that makes the most sense. Yeah, and there's not terribly much work yet to show for that one. So, but okay. Yeah, thank you for bringing that up because that actually helps me in designing the test this week. Because I don't think I want to do as a free response. I think free response most likely I would do stuff like find the board problems, which is actually just a nice little segue because now it's 9:25. Like something like number 3, if I asked you to use the limit definition to find f prime of 2, like yeah, I want to see your work, right? That would be a free response question for sure. But number 4 could probably be more like a multiple choice. And of course, writing the limit definition and then writing this in 2 different ways. Remember, we have an alternative definition. So just to give you a little hint here, you're going to look at section 3.1 here. Here, you're going to look at section 2.4 and section 3.2, page 8. Here, use 1 to limit definition for f prime of 2. So remember, for number 3, you're going to be doing f prime of 2 plus h minus f prime of 2 over h. The limit is h approaches 0. Or you can find f of x first, f prime of x. Using this. Then get f prime of 2. Then you have to write the equation normal line x equals 2. 4, just use the power rule. 5, obviously use a calculator, and the rest should be pretty straightforward. Make sure for 5 you're in radian mode. But I trust you guys can do the end deriv part. I'm not too worried about that. So I think 1, 2, 3, 4, 5 are great way to do this in breakout rooms. I'll do probably groups of 3 in the breakout rooms. I'll come by and just check on you guys once we get started, see if there are any questions. We'll do this for about like maybe 20 minutes. No, 15 minutes. I think 15 minutes should be enough. So it's about 9:26 right now. So about 9:42, we'll come back and we'll have a quick discussion. So again, number one, look at section 3.1 notes. Number two, look at sections 2.4 and 3.2 page 8 notes. Number three, you could use this or find f prime of x. Plug in 2, of course. Write the equation normal. 4, just use a power rule. That should be really fast. 5, use your calculator. Make sure you're in radio mode. I think 1 through 5 should be good practice right now. So let me stop sharing, stop the